Welcome to this explainer on arc extinction theory. Today, we're diving straight into the brutal physics of what happens, the exact moment circuit breaker contacts separate under load. We're talking about the intense, high-stakes battle between vacuum and SF6 technologies. Now, you might think that simply opening a breaker instantly stops the electricity, right? But here's the thing. Mechanical separation does not equal electrical interruption. The instant those contacts pull apart under a heavy load, the electricity actively fights back. It wants to keep that current flowing. And how exactly does it fight back? Well, it forms an electrical arc. Picture it almost like a living entity, a bridge of superheated, highly conductive gas that wants absolutely nothing more than to survive the interruption. It's violent, it's incredibly hot, and it is the absolute enemy of a safe electrical break. So how do we actually kill it? Extinction is a very specific physical process. First, the breaker physically stretches the arc. Second, it cools it down using a surrounding medium. But the real magic? That happens at step 3. The breaker waits for the exact microsecond the AC waveform crosses zero, and then it snaps the arc out of existence. Every single breaker technology out there exists to make that zero crossing kill permanent, instead of letting the arc restrike. To make sure that zero crossing kill kills sticks, marine switchgear basically relies on two primary ambient substances. On one side, we have vacuum technology. It's highly efficient, incredibly quick opening, and virtually maintenance-free inside its sealed bottle. On the other side, sulfur hexafluoride, or SF6 gas. It's odorless, colorless, non-toxic, non-flammable, and it boasts excellent heat transfer to quench that arc. Both get the job done, but they behave very differently when put to the ultimate test. Okay, let's put you in the hot seat for a second. Quick check for you. You open the SF6 breaker room right after a massive fault trip, and you immediately catch a sour, unusual smell. What is your very first move? Think about it. Your switchgear just interrupted a huge fault, and now the room smells wrong. Are you going to go in and inspect it? Stop right there. Here is the life-saving mandate you absolutely must remember. Sour smell equals ventilate first, enter second. Do not go in yet. That sour smell, that's not the SF6 gas itself. Pure SF6 is completely odorless. That smell is a dangerous decomposition byproduct. It's created when the incredibly hot electrical arc physically burns and breaks down the SF6 gas during a fault. It signals a totally hazardous environment, meaning you have to thoroughly air out that compartment before you or anyone else breathes it in or does any work inside. Safety always, always comes first here. Next up, ABB medium voltage breaker models. Let's map these concepts onto some actual hardware. When we map these two extinction technologies onto the dominant ABB ACS6000c breaker models, a pretty clear divide emerges. The HD4 uses SF6 and, importantly, is currently in production. But look at the HL3 and HPA. Both use SF6, but they are legacy models with discontinued production. Meanwhile, the VD4 breaker and the V-contact contactor, they both use vacuum technology, and both are very much in active production today. Knowing this, let's test how you'd actually apply this hardware knowledge in the field. Imagine you're told to source spare poles for an H3 breaker on a 20-year-old platform supply vessel. What's your realistic sourcing plan here? Well, the stark reality is that you're dealing with a legacy breaker. Since HA3 production has totally ended, you can't just order it off the shelf from the manufacturer anymore. You're going to have to rely on secondary markets or legacy parts channels first. But the real takeaway? You need to immediately start planning and budgeting for an eventual VD4 vacuum retrofit. Never assume you'll have indefinite spare support for discontinued hardware. You've got to plan ahead. This single sourcing challenge actually highlights a much broader, undeniable movement in the maritime world, a decisive industry shift toward vacuum technology. SF6 is certainly hanging on, actively produced in the HD4 model line, sure. But if you're commissioning new build tonnage today, you'll almost exclusively be working with vacuum systems like the VD4 and V-contact. They're cleaner, they're practically maintenance-free, and they completely bypass those sour-smelling SF6 decomposition hazards we talked about earlier. So, I want to leave you with a final, somewhat provocative thought to take away from this explainer. The next time you walk down into your switchboard room, I want you to take a really close look at the nameplates on your gear. Are your vessel's breakers a supported modern asset, or are they a ticking obsolescence risk? Because understanding arc extinction isn't just about knowing the physics of a zero-crossing kill, it's about deeply understanding the life cycle of the incredibly powerful equipment that's keeping your ship alive. Thanks for joining me, and I hope this empowers you to go investigate your own switchboards today.